first topic is circular motion. Now, what exactly is circular motion? That's a good question. Uniform circular motion is motion along a circular path in which there is no change in speed, only a change in direction.
In circular motion, there are three main points. There is always a constant velocity tangent to the path. There is a constant force towards the center. And when central force is removed, the object continues to move in a straight line. Centripetal force is needed to change direction. The formula for centripetal acceleration is centripetal acceleration equals velocity squared over the radius. The formula for centripetal force is centripetal acceleration times mass. Another formula for centripetal force is mass times velocity squared over radius. Let's do one example. A 3 kilogram rock swings in a circle in a radius of 5 meters. If the constant speed is 8 meters per second, what is the centripetal acceleration? The first step for these types of problems is to write down the formula. The second step is to plug in the numbers, which for this case the velocity is 8 and the radius is 5. The third step is to solve. 8 squared is 64, and 64 divided by 5 will equal 12.8 meters per second as the centripetal acceleration if you solve properly. Let's do another example. Find the centripetal force if mass is 300 kilograms and centripetal acceleration is 2.5 meters per second. The first step is to write down the formula. The next step is to plug in the numbers. For mass, it's 300, and for centripetal acceleration, it is 2.5. The third step is to solve, and you will get 750 newtons by multiplying 300 times 2.5. The last and final example for this section is find the centripetal force of a car if the velocity is 20 meters per second, the mass is 300 kilograms, and the radius is 10 meters. The first step is to write down the formula. The second step is to substitute in the numbers. Mass is 300, velocity is 20, and radius is 50. The third step is to solve. 300 times 20 squared is 120,000, and divide that by 50. The final answer for centripetal force should be 240 newtons. A real-life example of circular motion can be shown with this demo. The cup and the water inside will stay on the board as long as the cup is centered and the speed is constant. This allows centripetal force to keep the cup steady as it gives an illusion that the board is the floor. We are now moving on to the next topic. The second topic is torque.
What is torque? Torque is a twist or turn that tends to produce rotation, a force that causes change in rotational motion. Torque is determined by the magnitude of the applied force, the direction of the applied force, the location of the applied force. The formula for torque is torque equals torque, or force times radius times force times radius.
Got it.
See, look, mine's could be. See, mine's can be already done.
Give me a second.
I'm gonna email this to me.
Can you hold this for me for a second? Just aim it here. Thank you. I'm trying to shoot it for something. Class. This should be closer. It's a mini teeter-totter. Are these two weights balanced on the seesaw? We can use simple math to find out. The first step is to write down the formula to find the weight.
The next step is to substitute in the numbers for the mass and the gravity. We now have the weight, or the F, or force, for torque. Next, we write down the formula for torque, which is force times radius equals force times radius. Next, we substitute the numbers for force and radius. And lastly, we multiply to find that the two weights are balanced. We are now moving on to the next topic. Our third and final topic is gravitational force.
What is gravitational force? Gravitational force is the force of any two objects' natural attraction.
A real-life example of gravitational force is the attraction between Earth and the Sun.
Gravitational force equals gravity times mass 1 times mass 2 over radius squared.
Let's try an example for gravitational force. What is the gravitational force of planet 1, which is 5.98 times 10 to the 24th power, and planet 2, which is 7.26 times 10 to the 22nd power, with the average distance being 3.84 times 10 to the 8th power? Just like for any other problem, you'd start out by writing out the formula, which in this case is gravitational force equals gravity times mass 1 times mass 2 over radius squared. The next step is to substitute for gravity 6.67 times 10 to the negative 11th power, and the two masses, which are 5.98 times 10 to the 24th power and 7.26 times 10 to the 22nd power for the masses, and for the radius, 3.84 times 10 to the 8th squared.